So the plan for today is, last time we talked about sets, relations, and functions. And what I want to do today is talk about the ways that we have to describe a function. So just like if you're talking about the physical world, we need to have some vocabulary in order to describe the things we see. We want to be able to talk about the shape of something, or the color, or the taste, or the smell, so that we can compare and contrast things, right? We want to develop a similar language to talk about functions and relations. We want to talk about what some of the properties are and give some names to certain properties so we can compare our different functions and relations. So the next day or two, we're going to be talking about what some of these different ways are that we can compare them, or these different attributes that the functions have, so that we can build up a vocabulary so that we can do some of these comparisons. Is everybody okay with that idea? Hopefully that makes sense, that we're looking to define some adjectives so we're able to describe what it is that we're seeing. The first attribute that we're going to talk about, well, it's really attributes, there's two of them, is we're going to talk about domain and range. So when we say domain, I'm really talking about the x's that are used in that function or relation, and the range is about the y's. So that's what we're doing, is we're describing all the x's or x coordinates that are used in our function for the domain, and the range is that we're going to describe all the y's or y coordinates that are used in our function or relation. So let's look at some examples. So let's say our relation is described using a mapping diagram. God bless you. You're welcome. So let's say we have this mapping diagram that I've drawn here describing our relation. As a review from last time, is this mapping diagram representing a function, yes or no? Yes. Good. We know it is because each of the domains are used, and each of the domains are only paired with one of the ranges, right? The things on the left are only paired to one thing on the right. Everybody okay with that? Okay. So the domain is the set of x's that are used by the function. How many x's do we see used by this function? 4. So that means that we have a finite set. So we can represent this set by just using our curly brackets and listing those objects. In this case, I would list -6, 3, 1, and 10. Now, note that I happen to write these x's in order from smallest to biggest. The order that you write the members of your set does not matter. In fact, I didn't write them from smallest to biggest. Excuse me. But the order you write them does not matter. So the definition of a set just requires that there's no repeated members of the set. It doesn't dictate the order in any way. We do not need a specific order when you write your domain and range. You just got to make sure it's all in there. The order in which it appears does not matter. Everybody okay with that idea? Okay. Let's do the range then. How many things are in our range? 3. Good. So that's finite as well. So I can just list my 3 members of my range using the curly brackets again. I want you to observe, though, how many times was the range value of 0 used? Twice. Note that I did not list it twice when I wrote my range. The reason I did not is that when we defined a set, we said explicitly that it has no repeating elements or members. So even though 0 was used twice in the relation, I only listed it once when I wrote the range. Whenever you're writing a domain and range, you're never going to list a repeated element repeated times. So even though 0 is used more than once, we only will list it once. Let's do another example. I guess before we do, any questions about this first example? Okay. So let's say our relation is represented by this set of ordered pairs. As a review from last time, is this a function, yes or no? No. What's the problem? Yeah, the -1 in the x's is used more than once. Good. Okay. So let's write down the domain. How many members are there in the domain? 3. Note, you had to be a little bit careful there. I heard some people say 4 initially. Remember, what are we not counting? The repeats. So notice that -1 is used twice. I'm only counting it once. So I have only 3 things in my domain. The fact of the matter, though, is that 3 is a finite number, so I can just write my domain as a list using the curly brackets. Similarly, for the range, I see that that has 4 members. So once again, I can write this as a list. Everybody okay here? Now, remember from last time we met, we talked that there were 2 kinds of sets. There were finite and infinite sets. Occasionally, or maybe I should even say frequently in this class, our domains and ranges are going to be infinite, or contain, or be infinite sets, I should say. We talked also last time we met that the notation I gave you for these infinite sets was something I would not expect you to be able to generate on your own. We're going to present an alternate notation today for dealing with infinite sets that we can use when we're dealing with domains and ranges and some of these other descriptors that is much easier to use that I would expect you to be able to do on your own. That alternate notation is called interval notation. So I'm going to take a little aside and talk about how to do that and what that is. So not every infinite set can be written using interval notation, which is why we don't just use it for when I introduced the idea of an infinite set, why I didn't just start with this. But everything that you're going to see in this class from an infinite set standpoint can be written using interval notation. So if I ask you to describe a set, or I ask you to write down like a domain and that set is an infinite set, this is the notation that I would expect you to be able to use. This is called interval notation. And what interval notation looks like is it's a lower bound, comma, and then an upper bound. And we'll talk about what I mean by lower bound and upper bound in a moment. But it's one of those things that is much easier to kind of see an example of than to write a formal definition on. And then to begin, I'm either going to have a bracket or a parenthesis, depending on a condition later. And I'll talk about how we make that decision about which one we want to use. But they don't need to be the same. So one could start with a bracket but end with a parenthesis or vice versa. Or they could be both the same. Okay with that idea? All right. So let's do some examples of writing some infinite sets using interval notation. So we can kind of talk about what we mean by lower and upper bound and how to make the decision whether we should have a bracket or a parenthesis in a given location. So let's say the set that I want to describe are the numbers that are or the number such that 3 is less than or equal to x, which is less than or equal to 10. So if I'm going to write my interval notation, I want to start by writing a lower bound. What's the smallest number involved in the things between 3 and 10? 3, right? Not a trick question. That's my lower bound. The biggest number involved here is 10. That's going to be my upper bound. Now what I need to do is I need to indicate whether or not those boundary values should be included or should not be included. So let's first look at the lower bound. So I'm going to look at this part of my inequality. If I substitute the 3 in for x, do I have a true statement? Is 3 less than 3? No, right? That's not true. In the case that it's not included, I'm going to use a parenthesis. So the parenthesis indicates to me, if we're talking about the numbers between 3 and 10, we're not including 3 in those numbers from 3 to 10. Which is what this inequality states, right? Is everybody okay with that idea? Yes. Okay. So now let's look at the upper bound then. So the upper bound is involving 10, so I'm concerned with this part of the inequality. So I'm going to do the same thing. I'm going to plug the upper bound in for x. Is 10 less than or equal to 10? Yes, right? So since that is a yes answer, 10 should be included in this set. So I'm going to use a bracket. So if your set is described using an inequality like this, if it's a strict less than or greater than, you use a parenthesis. If it's the less than or equal to or greater than or equal to, use a bracket. Is everybody okay with this first example? Okay. Let's do another one. How about if we just have 5 is greater than x? I'm sorry, x is greater than 5. Read the right thing. In this case, what's the lower bound? The smallest number involved here is 5, right? Because we're talking about all the x's that are greater than 5. What's the biggest number involved? Anything. So do we have a more mathematical term to represent that? Starts with an I. Infinity. Okay? So good. The upper bound is infinity. The way we write the symbol for infinity is a sideways 8. So that's my symbol for infinity. And when we talk about positive infinity, I usually stick a plus sign on there. For the positive infinities, it's not necessary to include the plus sign. I like to include it because it helps me make sure that I put the positive infinity as an upper bound, because you can't have positive infinity as a lower bound. And likewise, the other option, if you're talking about, say we had x less than 5, we would have negative infinity as the lower bound. There you must have the negative sign to indicate that it's the negative end. Anyways, this was just like an aside. We're not actually going to finish that one. Although after we finish this one, you certainly could. So, now we need to decide brackets and parentheses. For the 5, if I replace the x with a 5, is 5 greater than 5? No. So I should say that 5 is not included. So I would use a parenthesis. Okay then? To stretch? Okay. Is infinity a real number? Is that something we can have a value for x? No, right? That's kind of like a concept. Infinities always get a parenthesis for that reason, that it's not an actual number that x can take. It's like a conceptual thing. So infinities always get a parenthesis. So far, so good. Hopefully this notation feels a bit more manageable than the infinite set notations we looked at earlier. Quite a few less symbols to kind of get a hang of, right? All right, let's do another. So for this one, we have the compound inequality. We want the x's that are less than 3, or the x's that are greater than or equal to 6. So the way that we deal with a compound inequality like this is we just take it one piece at a time. So let's just look at x is less than negative 3 and pretend that's by itself. What's the lower bound for x is less than negative 3? So think about the numbers that are less than negative 3. Are they getting bigger or smaller? Smaller, right? So negative 3 is the upper bound, but the lower bound is negative infinity. Is that okay with everyone? Right, so if you list the numbers that are less than negative 3, it's often easier to make sure you have the upper and lower bound correct if you find yourself wanting to answer the wrong spot. just list the values that fit the inequality, and that often prevents you from making that kind of mistake and flipping the wrong ones, or flipping the bounds. Okay, so looking at the negative infinity, bracket or parenthesis? For the infinities, always parentheses. Now let's look at the negative 3, bracket or parenthesis. What kind of inequality do we have? A strictly less than. So should we use a parenthesis or a bracket? Parenthesis. Now for the or, the symbol that we write there is this like capital letter U with no tail on it. That's the symbol for union. It basically just means or in set language. So if you're connecting some sets together, typically you're using that union symbol to kind of connect them together. Saying it could be this set or it could be in that set. Those are the X's that I'm concerned about. Everybody okay with that idea? So that's just the symbol you use. Let's move on and look at the next part, which is X is greater than or equal to 6. So the lower bound for that X is greater than or equal to 6 is 6. Okay. Good. The upper bound is good. Positive infinity. And then for the positive infinity, bracket or parenthesis? Parenthesis, that was the easy part. And for the 6, bracket or parenthesis? Bracket. Why is it a bracket here on the 6? Because it's an or equal to, right? Because if X equals 6, that inequality is still valid, right? Do we feel okay on using these interval notations? Okay. So let's return to our domains and ranges. And we'll do another example. Actually, let's do this. So, first thing we should do is just kind of take a look at this graph, because you notice maybe there's a symbol going on here that looks a little unfamiliar. Potentially this piece, you look at that and you maybe don't know exactly what that means. So let's talk about that as an aside here. So you remember back in Algebra 1 or pre-algebra, if you were asked to graph something like x is greater than 5 on the number line, you drew like an open circle and drew like an arrow to the right. Everybody kind of remember doing that in pre-algebra or algebra? What did the open circle represent there? It told us that 5 was not part of this inequality. It didn't satisfy this inequality. 5 wasn't included, that we're starting with the first decimal immediately after 5. Everybody kind of remember that? The open circle here on this graph is the same thing. So it's just telling us that that point 7, -4, where the graph ends, is not actually part of the graph. It ends like at the first point to the left of that. Now we can't write that down, because in this case it would be 7.0000000, as many zeros as you want to write, and then a 1, right? You kind of get that idea? Okay. Yes. Of course. Absolutely. All right. So let's write down our domains and ranges here. So when looking at a relation that's described with a graph, when I'm doing the domain, I want to start on the left side of the graph and then move to the right. So what's the first point I encounter on the left? -5, 3, right? Everybody agree with that? That's the first point I encounter on the left. So the domain is the x's. The lower bound for the domain then is going to be that first point I encounter on the left, or the x-coordinate, I should say, of the first point I encounter on the left. So that's going to be -5. The upper bound for the domain is going to be the x-coordinate from the first point I encounter from the right, which is, in this case, 7. Everybody okay with how I determine the upper bound and lower bound here? All right. Now I need to look at whether I should use a bracket or a parenthesis. If I look at where the -5 comes from, I notice that that point is filled in. That means that point is included in the graph, which means it should be included in my domain, which means I should use a bracket. To determine whether I should use a bracket or parenthesis on the 7, I'm going to look at the point where the 7 comes from. I notice that that point is an open point, which tells me that that is not a point on my graph, which means it should not be included in my domain, which means I should use a parenthesis. Is everybody okay with that idea? Now let's do the range. So to do the range, we're talking about the y-coordinates. So instead of looking left and right like I would for the x's, I'm going to look up and down. Right? Because the y-axis goes up and down, as opposed to the x-axis, which goes left and right. So to find the lower bound for the range, I'm going to look for the first point I encounter as I move from bottom to top. That point is 7, -4. And because I'm talking about the range, I'm concerned with its y-coordinate. So the lower bound for the range is -4. Yes, sir. Absolutely. To determine the upper bound, I'm going to do the same thing, but I'm going to start at the top and go down. So starting from the top, the first point I encounter is -5, 3. But since we're talking about the range, I really want just its y-coordinate, which is 3. Everybody okay there? Okay, let's determine now the brackets and parentheses. For the -4, that comes from the point 7, -4, which is an open point, which tells me that point's not included in the graph, so it should not be included in my range, so it should get a parenthesis. Now let's determine what we should do with the 3. So if I look at the 3, that comes from the point -5, 3. That point is a filled-in point, which tells me that point is a member of the graph, which tells me it should be in my range, which tells me I should use a bracket. Questions on what I've done here? We're going to do several more examples to make sure that we've kind of seen a good variety of possibilities. Madison. Correct. Yep. Let's look at some more examples here. So let's write down the domain here. What's the lower bound for the domain here going to be? -7. Very good. The upper bound should be, it's not going to be 3. Notice that this arrow at the end of the graph is pointing to the right and down. The fact that it's pointing to the right tells me this graph keeps going to the right forever, correct? So the last point used is going to have what for the x-coordinate? Positive infinity, yes. Everybody can kind of see that? Look at all this part of the graph that happens after the point 3,5. 3 cannot be the upper bound for my domain because the graph keeps on going to the right after that point. How long does it keep on going? Forever, which means we have the positive infinity there. Okay. For the -7, should I have a parenthesis or bracket? Should be a bracket. Notice if I go and I look at the point that -7 comes from, that is a filled-in point, which means that point is part of the graph, and it should get a bracket in the center. How about the positive infinity? Parentheses. Infinities always get a parenthesis. Let's do the range. The lower bound for the range would be? It's not -10. It is -infinity. We have an arrow pointing down, which means all the stuff from the arrow is going to be below -10. The upper bound here would be +5. That's the highest point, or the y-coordinate from the highest point. Okay. For the -infinity, bracket or parenthesis? Parenthesis. Always a parenthesis on the infinities. For the positive 5, bracket or parenthesis? Bracket. If I look at the point corresponding to 3, 5, that's a closed point or filled in point. That means it's included, which means bracket. That was a tricky one. The arrow at the end there made life a little bit tricky. I think I fooled everybody on that one. That's okay, though. That's why we're doing them as examples, right? Better to be fooled now than to be fooled later. You know? Shh. That's all you need. You guys are smiling at me like you're waiting for me to write more down. That's all we need. Let's do the domain first. What's the lower bound on the domain? Negative infinity. Notice we have an arrow that points to the left and down. Since it's pointing to the left, it's going to go to negative infinity. The upper bound is positive infinity. We have an arrow that's pointing up and to the right. Because it's pointing to the right, it's going to go in that direction forever. And since they're infinities, they both get parentheses. Let's do the range. The lower bound is negative infinity. We have an arrow that's pointing down. Because it's pointing down, it's going down forever. That gives me a lower bound of negative infinity. And the upper bound is positive infinity. Notice we have an arrow that's pointing up. Tells me the graph goes up forever. So we have positive infinity. Because they're both infinities, they both get parentheses. Whoa. Everybody okay with this one? The alternative way to say this is also all real numbers means the same thing. Those of you taking the ACT, they'll often use that written in words rather than the interval from negative infinity to positive infinity. They'll often say all real numbers instead in that sort of situation. Just as a heads up. Okay with that? Do we feel decent about domains and ranges? Obviously, you probably need some practice still, but you feel like you can start practice with what we've done so far? Okay. The next descriptor that I want to talk about is positive, negative, 0, so when we say positive, negative, 0, positive means where the y-coordinate is positive. Negative means where the y-coordinate is negative. And 0 means where the y-coordinate is 0. Whenever we ask a where question in mathematics, the answer is always going to be given as x-coordinates. So when we describe where the graph is positive, we're going to describe the x-coordinates where the graph is positive. Okay? Similarly, negative and 0. So when I look at a graph, and I am looking for the positive parts of the graph, I need to look at the parts that are above the x-axis. Those parts will all have positive y-coordinates, correct? Similarly, negative is going to be below the x-axis, And then 0 is going to be on the x-axis. So if we're looking at the parts of the graph, the stuff on the x-axis are my zeros. The stuff above the x-axis are my positives. And the stuff below my x-axis are my negatives. Everybody okay with that idea? To just kind of visualize what it is that we're discussing right now. Let's look at an actual example now. More often than not, when we're talking about positive, negative, and 0, we're going to be looking at a relation represented as a graph. So all of my examples here will be graphs. They need not be, but it's beyond the scope of this class to really ask you to deal with anything other than a graph. So if I look at this graph, how many different parts of this graph do you see that are positive? 2. I see this part on the right, and I see this part on the left. And when I said left and right, I reversed what I actually pointed to, right? Okay. How many parts do you see that are negative? 1. I see just this part in the middle. And how many parts do we see that are 0? 2. See this part and that part. Everybody agree with those sightings? Okay. So if I'm going to do the positives, I'm going to be looking at describing the where the graph is positive. So I'm going to talk about those x-coordinates. Everybody agree with that I highlighted? And my other part that's positive is those x-coordinates. Everybody agree with that? Okay. So if I look at that positive piece on the left, that piece begins with what x-coordinate? -5. And it ends at what x-coordinate? At -3, right? Everybody agree with that? But if we're talking about this piece here, that piece starts at -5, 6, and ends at -3, 0. So it begins at the x-coordinate of -5, and it ends at the x-coordinate of -3. Is that okay? Madison, you're making some faces. You got it? Okay. I just want to make sure. I figured if I just pause long enough, that would sink in. That's good. Okay. Let's now determine whether they're brackets or parentheses. Let's start with the -5. What I'm going to do is look for the location of the point involved with -5. That's that point there, -5, 6. Is that point above the x-axis, since we're talking about positive parts? Yes. So it should be included with the positive points. So that's going to get a bracket. I'm now going to look at the -3. That point is located here at -3, 0. Is that part, or is that point above the x-axis? No, it's on the x-axis. That does not get included with the positives. That should be included with the zeros. Okay. Now I'm going to do the union, and I'm going to deal with the other positive part at the far right-hand end of my graph. What's the x-coordinate of the point at the start of that next positive part? 4. And the x-coordinate at the end of that positive part? 5. Everybody okay with that? Okay. Let's look at the point that corresponds to the 4. That's this point right here. Should that have a bracket or a parenthesis? Parenthesis, because that point isn't above the x-axis. It's on the x-axis. That point needs to be put in with the zeros. Now let's look at the point that corresponds to the 5. That's that point 5, 2. Notice that point is an open point. So it's going to also get a parenthesis. Even though it's above the x-axis, there's no point there at the 5, 2, because it's an open point. Everybody okay with that idea? All right. Let's do the negatives. What's the lower bound for our negatives? Where does that negative part start at? -3. And where does it end at? 4. Everybody agree with that? We're just talking about this section there in the middle. If I look at the point that corresponds to that -3, is that below the x-axis? No. So it should get a bracket or parenthesis? Parenthesis. If I look at the point that corresponds to 4, bracket or parenthesis? Parenthesis. Now let's do the 0 parts. Oops. What's different about the 0 parts and the negative or positive parts? How many points are included in the 0 part? 2. How many points are in the positive parts? Infinite, because they're segments. How many points are in the negative part? Infinite, because they're segments. Everybody okay with that idea? Remember, on any line, there's infinitely many points. That was one of our axioms from geometry from last year. You guys kind of remember that? Or at least after I mentioned it. So, we used interval notation when we described the positive and negative parts because those were infinite sets. To describe this part with the zeros, I'm going to use finite set notation because there's just literally only 2 points that are 0. So I can just list the x-coordinates from those 2 points. That's it. Let's do another example. Easier to see here. But actually, let me do that. That makes it a little bit more fun. Okay, how many positive parts do we see? I see 2. So one at the very beginning, and then another at the very end. How many negative parts? 1, just this piece right here. How many 0 parts? 2. There's this part here, and that part there. So the positive part begins at -6 and goes all the way to -3. That part right there. Everybody okay with that idea? So it goes from -6 to -3. If I look at the positive part, the -6, that point is above the x-axis, so it gets a bracket. If I look at the -3 that's on the x-axis, that gets a parenthesis. And then I'll do my union. And my next positive part starts at +5 and keeps on going. So it goes +5 to +infinity. If I look at the point corresponding to that +5, I notice that's on the x-axis, so it's not positive. And then I know the infinities always get a parenthesis. The negative part is here. That's going from 2 to 5. The point that corresponds to the 2 is both on the x-axis and open. In either of those situations, it should get a parenthesis. The point corresponding to the 5 is on the x-axis. That's not a negative point, so it should also get a parenthesis. The tricky part here is the 0. So the first part of my 0 interval starts at -3 and ends at +2. The -3 is on the x-axis. That means it is a 0 point. It should get a bracket. The 2 is on the x-axis, but it's an open point. Since it's an open point, it's not actually there. It gets a parenthesis. And then the last 0 part is just a singleton point. That's finite because there's just a single point there. So I'm going to jump back to the finite set notation. And write that as a finite set rather than as an interval, which is an infinite set. For tomorrow, I have posted another homemade worksheet to PowerSchool, and when I say tomorrow, I mean next class period, which is not actually tomorrow. Make sure that you read the directions, because although I use the same relations as the last sheet, I'm asking you to do something different with them. And then there's 2 problems past what you had saw last time, just as a heads up.